right, welcome to the Lab Zero Programming the Target Computer section of the book and of this lecture series. I'm Dr. Rico Piccone, and I'll be going through a section of this book that I wrote with Joe Garbini and Cameron Devine. You can check out the book on the MIT Press website there and rtcbook.org. Okay, programming the target computer. The purpose of the lab is to learn foundational skills for programming the T1 target computer, which is the MyRio, and interacting with the keypad and LCD. Key objectives: develop programs in the D1 environment and run them on the T1 system. So the development environment will write the program, develop it, and then deploy it onto the T1 target system. Design a program and understand pseudocode. So we introduced pseudocode in this lab to learn about that and how to use it. Write and debug a C program for the T1 target computer. So we'll write and debug a basic program. And preparation requirements for the lab. Set up the D1 development environment as described in section 0.2. So you have to go back a few lectures for that. Use the T1 components listed in Appendix B. There's a table there that lists the components required for each lab. Follow the setup instructions for your specific T1 version in Appendix A2, which is also available on the website. Refer to the online resources section for setting up this lab exercise. So this is the link to, the short link to the lab exercise description on the website. Okay, the adding machine program. This is the program we're going to be writing together for this lab. So the objective of the program is to transform the MyRio keypad and display into a simple adding machine. Requirements: 1. Present the current total on the display, starting with 0. 2. Support the addition and subtraction of floating point numbers with user input via a keypad. 3. Let the entry of a positive number imply addition and a negative number imply subtraction. 4. Exit the program if 0 is entered. The purpose of this program is to introduce fundamental programming concepts such as user input, floating point arithmetic, and control flow. So, designing the program. Pseudocode is introduced in this lab. It's a high-level description of a program that uses natural language to outline its logic. So we don't worry too much about the syntax or the details of implementation for the program. In pseudocode, we write out the logical structure of the program. The following two algorithms, which are written in pseudocode, describe the main program and the interactive adding function. So algorithm 1 is the main pseudocode. The main function opens here. We open an FPGA session on the MyRio and check for success. That's the first step in the main function. Then we're going to call another function, the interactive add function. And then once that interactive add function is finished, we'll close the FPGA session and return the status. So the main code essentially is going through what we learned a couple lectures ago, which is how to open up a MyRio session, how to call another program or do some steps in the body of the program, and then have at the end the closing of the FPGA session. Okay, algorithm 2, which is called from this interactive add call here. So this is calling algorithm 2, interactive add. So this function takes an argument, t, which is the total. And that's where the total is going to start. So we could start at any value, but we'll call with 0 as the default in our program, because usually you would start at 0 when you're about to add a bunch of numbers. Declare and initialize variables, then we enter a loop. And when the user's entry is non-zero, so if they enter a positive number or they enter a negative number, it'll continue to loop through this block of code until the user enters 0, which is the sign that the user gives to the program to end the program. So print the total to the display, prompt the user for keypad input, receive user input from the keypad, and then I should have also said update the total, update T. Okay, so those are the steps that we'll need to take in our interactive add program. So here is a main program that I recommend. In this lab, we're giving you the code that you need. In future lab exercises, you're going to be writing all the code yourself, but for the first one, it's kind of nice to have the guide. But go through it in detail, try to understand every line of it and why it's there. This is essentially the same structure as the program that's written in the stub main.c file, which checks the myRio status. And if it's not good, it will exit the main program immediately and give an error code. Once it's done with that, we'll call interactive add and we'll start at 0. Once that exits, the program will return to this location after interactive add and do the end matter. So it will close the myRio FPGA session and return the status of that call to close. If everything is good, then the status will be 0. Okay, so that's the main program. Pretty straightforward. Good. So now we need to go into a little bit more detail before we write the interactive add function about how to get user input from the keypad and how to display values on the LCD. So the double in function is going to be a key function for us, and we'll later write this function. It's provided by the T1C library as a binary, so we can call it, but we won't be able to see the source code until we write that source code ourselves. So this function prompts the user by displaying a string and then returns the keypad entry as a double, a floating point number, when the user presses the enter key. Prototype, double in, it's a little light, but the function is double in. Car prompt, this is something that we'll come to understand a little bit more later, but for now we can just understand it as a string. Prompt example, double summand equals double in. You give it the prompt, so current total is 0. This is a special character, so the /n, the slash is an escape character. We'll learn more about these later. Escape character. And n, so the special character /n means new line. So almost all computers understand this character to be a new line character and will give you a new line when they encounter this. So our LCD is no different. When we see this, it will create a new line there. So we have a multi-line display, and it'll write total 0 on the first line, give us a new line, and then summand, colon, and then space will be printed. And then the user will enter a value. So this is the dynamic prompting with sprintf. So we don't want to hard code this total 0 in here. This prompt would be fine for the first call until the user enters a number and we want to update the total. So what we want is a formatted string so that we can dynamically insert the total. So this is how to do that. This declares a string. So declare string. And then use sprintf, which is a C function that is available in the stdio library, standard library, and that we'll bring in the program by including the stdio header. So the first argument is the destination string variable for this formatted string. So we're going to give it the variable we want to save the string to. We're going to give it the literal string, which has this special character string in it, which is %5g dot, which we'll get into the specifics of why that is a good choice. But this is a format string special character that tells us that we want a 5-character wide floating point number printed in this location. So that's the %5g. And the last argument is the actual value that we would like to insert into this location. So whatever the total is goes there, and then that string that's now formatted with the total in it will be saved to prompt_string. Using prompt string in double in, we'll display the current total. So that's our formatted string to pass to the double in function to prompt the user for a number to sum. Okay, so now we're ready to program interactive add. Interactive add function returns a double. It takes a double, which is the current total to start with, or the starting total. We're going to initialize the summand variable to -1. It could actually be any value as long as it's not 0, because the condition of our loop is going to be that summand is not 0. So we set it to -1. We initialize our prompt string. We declare our prompt string, I should say. And then we enter our while loop, which, as I said, will continue to repeat this block of code until the summand is, in fact, equal to 0. So we sprintf format string, save it to prompt string with the current total. We then pass the prompt string to the double in function, which prompts the user, and the user types in a number in the keypad and hits enter. When they hit enter, that value that they enter into the keypad will be read by the double in program and its supporting functions, and the value will be saved as a double type variable with the name summand. Summand then will be added to the total. So this plus equals, again, this is just shorthand for total equals total plus summand. So plus equals is a convenient shorthand notation. And finally, we'll return exit success if we have made it that far in the program, which means that it has been exited by the user pressing 0, enter. Okay, so we went through this in detail, so we don't need to go through those points at the bottom, but those essentially reiterate what we just discussed. Finally, as with every lab exercise, there is a lab exploration and evaluation section. Unlike the rest of the lab exercises, we have provided a complete program from the adding machine. Again, that's not going to be the norm. That's not going to be what we do for the lab exercises. But for this one, we're just getting used to the mechanics. So we have to go through that to begin. Typically, you will design and implement the program yourself. In this section, you'll explore how to build, run, and debug the adding machine program on the MyRio keypad and display. The tasks should be completed and repeated until you are comfortable with the process. So it takes you through and is essentially a tutorial on how to use the debugger, how to build and run your code. And I thought I would do a little demo of that for this first lab exercise. I probably won't be doing that much in the future lectures on the lab exercises, but just to make sure that you get started on the right foot, I'll do a little demo. Okay, so what we have here is the workspace that is in our virtual machine and visible in Eclipse. I have Lab 0 open, and I have the main.c function in lab 0 opened up in the editor window. So this is how all of the main.c files in these lab directories, these lab projects, are displayed. This is how they all look. They start with the same exact code in them. So it's up to you to come in and edit this introductory comment with your information, the lab description, and all that. Here are the include files. Here are the prototypes, this prototype section, definition section. And again, this is just a hello world program, but this should build and run. So I'm going to first clean the project, delete all of the built files. And if you want to make sure that the browser is showing the right thing, you can refresh, see, okay, we have no compiled files here, no executables. So now, since main.c is already a program that should be able to run, let's go ahead and build the project. Okay, it looks good in the console, so built successfully. We now have a binary section with a binary for lab 0 to deploy to the MyRio. So what I'm going to do is go to run configurations, and I'm going to choose lab 0 and the run configurations, and then I'm going to run. It will try to rebuild if it needs to. I'm going to show you the hardware as well. All right, so this is what we see on the MyRio. And on the LCD screen, we have Hello World showing up, which is what we had in our program. So let's try to edit. So we're going to put in multiple exclamations now for printf LCD, and we're going to recompile, or we're going to rebuild it, which you can also do by clicking that. And now that it's rebuilt, we're going to run configurations, lab 0. It has been modified. We're going to save changes, yes, although I think we rebuilt. If we didn't rebuild, no problem. We must have saved it before we built because the extra exclamations are showing up on the LCD screen. So that is how to get the Hello World working. Let's add a bit of a wrinkle to this. I'm going to copy, since that code is available on the course companion website, I'm going to just copy the main code and paste it in here, which I encourage you not to do. I encourage you to go through and put the code in manually yourself, but just for the sake of the video, I'll do this. For some reason, exit success is not showing as resolved, which may or may not actually be a problem. I think... oh, that comes in a different header. I have to add a header here. Let's include I think this one is standard lib.h. Okay. Yes. Okay, so now exit success is resolving. We could have just passed 0 there, but we needed to add stdlib in order to get that symbol. Okay, so now that that is resolving, this all looks good. Let's try to build this again. So let's build. And I'm getting oh, I got a warning from the compiler. It says implicit declaration of the function interactive add. Well, that's because It's a benign warning. That's because in prototypes, I didn't give a prototype of interactive add. So I'm actually just going to copy this, place it here, and put a semicolon at the end. Save. And let's try building again. Okay, no errors now in our build. So that's good. Let's go ahead and run it now on the MyRio and see what it looks like. So run configurations, lab 0. You can double click on it as well if you like. We can see now on the LCD that the total of 0 shows up and the summand prompt as well. So let's put in a number, say 5, enter. The total updates. That's a really good sign. Let's put in 9, enter. 14. Let's put in 563, enter. 577. Okay, this is all looking good. Let's do a negative number. Negative 56, enter. That's good. Let's put in a decimal number. 9.45, enter. That all seems to be working fairly well. So that's good. We haven't done the debugging activities, but I just wanted to show you the basics of how to get the program running. We could also take a look at the debugging while we're here. So going through, I want you to go through all the steps and the tasks. But to show you rather quickly, we need to exit this. So summand of 0, entered 0, exit. And our program has terminated back over on our development machine. So very good, that's all working well. Let's debug this. So now, if we go to the Run menu and we see we select Debug Configurations, again we can select Lab 0 and we can click Debug. Now we have entered the debugger. We have gone to this line here, which is the first function call, and we have the variables pane. We didn't set any breakpoints or anything like that, but we could set breakpoints even at this point. We could set one here for the interactive add. So let's continue this. Let's resume. It will stop at the breakpoint. Let's step into the interactive add function. Now we're in the interactive add function. And we will take a step. And here is our first while loop evaluation of the criteria. So let's step, and step. Okay, and now over on our LCD, we see that total is 0, so command is being prompted for. So enter 3 and enter. And we see that the command variable has a value of 3. The total still has a value of 0. The prompt string is a string, which doesn't look very interesting at this point. We'll kind of understand that more later. So let's go ahead and enter in 0 for the program to end, and it will exit. The debugger terminates as well, and we're done with that debugging session. We could start the debugger again in the debugging session again if we want. Notice that we switched over to the debug perspective. The C and C++ perspective is where we are editing our code, obviously. And yeah, that's how to do some of the some of the basic building, debugging, editing that you'll do in this laboratory exploration. I'll let you guys enjoy the rest of the process yourselves, and I'll see you next time, next chapter. All right, take care.